Okay, question number 6 says two boys, Sean and Curtis, went for a walk. Sean began walking 20 seconds earlier than Curtis. Sean walked at a speed of 5 feet per second. Curtis walked at a speed of 6 feet per second. For how many seconds had Sean been walking at the moment when the two boys had walked exactly the same distance? Okay, so if we were to think about this, I'm going to use two different colors here. I'm going to use the blue color to represent Sean, and I'll use black or red, another color, to represent Curtis. Okay, so let me just go ahead and write out Sean's name over here. Whoops. So this will be Sean will be blue, and then I'll use black to represent Curtis. Okay, so let's imagine we have both of these guys starting off at the same point. Okay, and what I'm going to do is I'm going to have obviously the blue kind of covered up the black there, but obviously both of them are starting at the same point. And I'm going to represent the x-axis for my graph that I'm going to make will represent the time that the two of these guys have been walking, and the y is going to represent the distance that they have walked. Okay, so distance, I'm kind of running out of room here. Oops, distance, there it goes. That's going to be like our y-axis. So Sean starts walking, okay? And so as the time goes, Sean is walking at a constant speed. He's not getting any faster. So since it is a constant speed of 5 feet per second, that means it is a linear function, okay? He's going 5 feet per second, never changing his speed, and he's walking some distance. Now it said that he had a 20-second head start, all right? So let's say that somewhere in here, let's say that maybe this is where 20 seconds was. Now, at that 20-second mark, Sean had walked a certain distance already, okay? And we can figure that out. If we think he's walking 5 feet per second for 20 seconds, we do 20 seconds times 5 feet per second, and that gives us a height of 100 feet, okay? So Sean had walked 100 feet, so he's actually 100 feet ahead before Curtis even starts walking. Right? Then Curtis starts walking. Now Curtis is walking at 6 feet per second. His is also a constant rate, but he's starting here at the 20-second mark, and since he's walking a little bit faster, that means his graph is going to be a little bit steeper. Okay? Now this isn't going to be drawn to scale. In other words, it's not going to be drawn perfectly. The time and the distances here won't work out perfectly as far as the scale. So we've just got to sort of we've got to come up with, figure out how long it took for Curtis to catch back up and actually be at the same distance as Sean was. So he's 100 feet behind Sean when he starts. Okay, but he's walking at 6 feet per second. All right, 6 feet per second. Didn't really draw too well there. Whereas Sean is walking only at 5 feet per second. So, if you think about that, that means every second Curtis is getting 1 foot closer to Sean. Okay? He's making up 1 foot every second. He's closing that gap between the two of them 1 foot every single second until that gap gets so small that it's back to 0. Okay? So he was 100 feet behind, and he's making up 1 foot every second. That means he needs an extra 100 seconds, okay, to close that gap. All right? And like I said, it's not drawn to scale, so this distance, if this was 20, you would think 100 would be a little bit wider, but I didn't know exactly how many seconds it would take when I started drawing this, so it's not drawn perfectly to scale. But I know that in order to make up a distance of 100 feet, in order to close that gap down to 0, it's going to take 100 seconds. Okay, and we could double check this to make, check this to make sure. So if Curtis walks 100 seconds at 6 feet per second, that's 100 times 6 feet, which is 600 feet. That's the distance he's walked. Now let's check Sean here. Sean has been walking 100 seconds plus another 20. Okay. So he's been walking a total of 120 seconds. And if I multiply that times his speed, 5, 0 times 5 is 0, 2 times 5 is 10, carry the 1, and 1 times 5 plus 1 would be 6. So that's also 600 feet. So in fact, they have walked exactly the same distance now. Sean just walked 20 seconds longer, so he has walked a total time. If you look here at the question, how many seconds had Sean been walking? It's not asking about Curtis, just Sean. Sean was walking 120 seconds by the time Curtis caught up, and they had walked the same distance. Okay, so our answer is 120.